There we go. All right, let's shift over to the problems that we're working on. Let's see, we're up to assignment 2 is, sorry, assignment 1 has already been due, and we're up to lab 4. This is what we did last time, right? What do people want me to do? We have assignment 2 that's due in 4 days. Now this assignment here, you should be very careful with this one and work work a lot on this, because this looks like what the quiz is going to look like, almost exactly. Look at this instruction right here. You should work out the answer to these problems manually without the use of a computer. Because when you sit for the quiz, and later when you sit for the final, I'll ask you questions that are just like this. And you will not, you're not going to type them into your laptop and compile and run them. You're just going to, with pen or pencil, write down a solution. So this is a good assignment to, the purpose of this assignment, the purpose of the format of this assignment is to get you ready to do well on the quiz. And the quiz is to get you ready to do well on the final. And the final is to get you ready to do well in a job interview, because believe it or not, in a lot of job interviews for software development in particular, that the employer who's interviewing you will sit you down and ask you to solve some problems. And they'll ask you problems developing some kind of an automated solution. Here you have a list of numbers. Write down the pseudocode or in any programming language that you want to work in, write down a procedure that sorts the list of values into ascending order. And take your time. I'll come back in 2 hours and see where you are. That's a typical interview experience for someone that's going out there and applying for new jobs. So this, what you're learning in here is really practical and really connected with what many of you are going to end up trying to do later on when you graduate. All right, that is assignment 2. And we could start, well, we could start looking at, well, not that assignment. Let's see. You want to review assignment 1? How many people successfully completed assignment 1? That's not too bad. So a lot of you had trouble with that. Do you want to talk about this one or move on to advanced topics that are coming up? Let's look at reading 4. The concept of scope, that's something that's important. All of these are important. How to implement and call functions. What are reference parameters? Stepwise refinement. Actually, we've been doing that all along. Stepwise refinement. How to use pseudocode. So on. Random colors. Why don't we do this one? So this one, someone asked me about or commented that she didn't understand how to use the rand function. So maybe I'll spend a little more time with the rand function right now and talk about that. Let's go ahead and do this exercise 1 in lab 5. So we need to reorganize the code that we produced to solve exercise 3 of lab 3. Let's see, exercise 3 of lab 3. Let me go there. This one here. So we're going to take a look at this exercise. Our solution to this exercise, we're going to reorganize it. We're going to try to make the code easier to read and to extend by using functions. Is this okay? Am I going in the right direction here? Anybody else have a suggestion of what we should do? Oh, okay. Let's see. I gotta find, so I think I have that in here. There it is. Here's our exercise 3 from lab 3. So we are generating, oh, we never finished this, right? So we need to generate this, this document with 100 list items that contain a random number. Is this right? Oh, this is wrong. This is the generation of a random color string. Am I on the wrong exercise? We're not generating a random color string here, right? Oh, that's the assignment. So that means we have to do the assignment. All right, let's do this assignment then, and then we'll reorganize this. All right, let's do that. Do you want me to work on Visual Studio or SSH? Okay. Let's go ahead and go over there. I'll start by copying code from this other lab. All right, this one here. Let's go ahead and solve assignment 1. And basically we're going to generate a web page that has these random colors in it. And I have maybe I'll use this code here. And I need to get that turned off. Somehow VI is configured to do something it normally doesn't do for me, which is to insert these numbers here. Does anyone know how to turn this off? right, so we have this a loop. So let's just get this running first. We're going to generate a web page with 100 random values. Okay, here we go. So we'll print the, actually it's hard to see it in the browser when we run on the remote machine. That's the problem. Now I realize the problem that you're having. You can't really see it in a browser. Let's see. When you're in the lab, you can open up the file that you generate in a browser, but when we're using SSH, we can't run a browser and see the result, because the browser is a graphics program and SSH is working as a console program. It only allows text data. It will only render text data. It won't render graphics data. All right. RAND was not declared in this scope. So here we're calling a function RAND, but the compiler says it was not defined in this scope. And what we need to do there is include something. And I think that is it C standard lib? Oh, that's for time, right? Now it's complaining about RAND. Oh, SRAND. SRAND was not declared in this scope. RAND was not declared in this scope, but time is not a problem. So we're handling time now. And is this right? Is it C standard lib? Does anybody know the include? Is that right? Okay. So it's a matter of finding the right header file to import to make sure that the function that you're calling is defined. So here on line 21, expected primary expression before return. All right, so we got a mistake there. Line 21. I'm going to jump right to line 21. I think the problem is the line right before it. Do you see the problem here? This slash is called an escape character, and the purpose is it precedes another character or sequence of characters that's used to specify a character that can't be typed in, or that can't be typed in and can't be placed inside of the string literal. So we want to put a new line in there. So some other choices there. This is called a character turn, and this is a tab. So these are examples of different escape sequences. This is called an escape sequence. \T. See, when the compiler goes to process this string, think about this. When it hits this point, it says, quote, this is the beginning of a string, a literal string. It's not a variable that refers to a string somewhere else. It's the string itself. So the compiler hits this quote and it says, okay, what are the characters? You want a less than, or an angle bracket, a left-facing angle bracket, whatever that's called, a forward slash is okay, an H, a T, an M, an L, a right-facing angle bracket, and now, I'm going to change that. Now, what I want is, so Sorry. What I want is a new line character, but I can't insert the new line character directly in there. If I hit return, see what I want is this. I want to return there. But I can't specify that in the string itself, so I use this escape sequence. So I need, so when the compiler gets to this point and it hits that slash, it says, whoa, this is a backslash. Okay, that's not a regular character. I'm going to consider what follows next to specify something that something special. In this case, an N refers to new line. So the compiler inserts a new line into the string that it creates inside computer memory. All right, let's see. All right, there's the 100 numbers. But you know, it's hard to work with 100. So instead, let's work with 5. It's hard to look at 100. It scrolls off to the top of the screen. So we'll set it to 100 when we're done. But for now, we'll just use 5. There we go. Oops. All right. Let's get the rest of these things in here. So we have an unnumbered list, followed by the list items, and then we close off the unnumbered list. And I'm skipping some steps in there. So we have this part. We have the opening HTML tag and the closing HTML tag. Remember, to close off a tag, you use a slash. So this is the start of the HTML element. This is the end of the HTML element. And everything in between the start tag and the end tag is the contents of that HTML element. So this whole thing taken together is an HTML element, which is an element that contains elements within it. So inside the HTML element is a head element. And the head element itself contains a title element. And the title element itself, it doesn't contain any other elements. It just contains text, character data. So here it's the same format. We have a start tag and an end tag, sandwiching something in between. Oh, this is an ordered list, OOL. So that's a list where they put numbers, where the browser generates numbers. So let's go ahead and do that. Oops. And so we have this. I left this out. We could put that in later. Now that's missing and this is missing. We'll put that in later. That's easy. So we have this opening ordered list tag and a closing ordered list tag, and then here we have the list items, 100 of them. But we're only going to do 5 for now. And each list item has it has this random value, random string that's embedded in it, but it appears in 2 places, here and here. So let's work in the direction of getting here. Let's suppose we have that string. And based on that assumption, let's look at what the code would look like. All right, let's suppose we have that string. I'll put it here. Let's suppose we have that string, and I'll declare that string here. This is our color string. There's a color string. Let's suppose that was randomly generated. Let's output that. So we have a list item. We have style equals quote, but we need to escape the quote. Actually, I'll do that in a second. So we do style equals, well, I better do that now. We escape the quote. And is color colon like this. Did I get that right? So these are the characters that we need to print. We need to print those characters. And then we'll print the random string. So we just need to print. How do we print these characters? That's all we need to do. In fact, it's easier to do it like this. I'm just going to copy that. We need to print those characters, and then we will print the random string. Then we will print these characters. Then we will print the same random string again. Then we will print these characters, and we'll print a new line as well. And then we're done. That's what we do inside the body of the loop. That ends up printing this. And then we just simply need to do that 100 times. So let's start by figuring out how to print this. So to print that, I'm going to call it this. It's the first part. And then we're going to print the color string. And then the second part. Then the color string again. And then the third part. So that's the shell of a solution right there, right? Print the first part, print the string, print the second part, print the string, same string, print the third part. And we have to do that 100 times. What is the first part? Another way to do this, let me, maybe this is easier for people. Print the first part, then print the string. This is an equivalent way of writing what we just wrote. So I'm rewriting this in a way that might be easier for many of you to understand. But it's, which form is easier to read? I think maybe it's a matter of opinion. And at the third part, we want to add a new line there, right? So just want to. We can even put the new line in a separate cout statement, just to break it out even further like that. Is that easier to look at? That's opinion, right? You got to do it the way your boss wants it to look, basically. Huh? Yeah, we need to include header for strings. That's correct. Thank you. It may be indirectly included through one of these existing headers. In fact, it's probably included through IOStream. Let's see. It is. See, I didn't include the string header. It's still built. And the reason is one of these other headers, in one of these headers, it has an include string directive in it. So it's being indirectly included. Well, I know that the string class appears in, I think it appears in here. But that could be compiler dependent sometimes, so you need to be careful. It's good to be explicit. Let's go ahead and put it in there. Sometimes another compiler will have a slightly different a difference there that you'll actually won't build on another system, but I think it'll build on other systems in this particular case. Okay, so let's go ahead. We have our color string here. Well, wait a minute. Let's run it. We built it, and let's run it. There it is. Okay, we're getting there. So you can see that color value is being repeated, and then we can repeat it any number of times like that. So now we just need to replace the first part, the second part, and the third part with what we need. I'm going to close this. I don't need that. And let's go back. Let's do the third part first. That's the easy one. That's the third part. No problem. I can build that. No problem. Run that. There it is. It's good. Looks good. Let's do the second part. The second part is this. That's going to be tricky because there's a quote in there. Look, I'm going to put that second part right there. Do you see the problem? This quote, we want to print the quote. But the compiler says, well, you started your string here, and oh, you're ending your string now. And what's next? Hey, that doesn't belong there. That's a syntax error. Missing terminating quote character. So we want the quote itself to be part of the string, but we use the quote as a string delimiter. Right? We start the string and end the string with a quote. So we need to escape the quote. We use a backslash, just like we used \n. Here we need to tell the compiler that, hey, special case, the quote doesn't terminate the string. I want this quote to be in the string. Okay, there it is. It's good, right? That's what we want right there. All right, let's get the first part now. The first part looks like that, and you see the problem there. We also have a quote inside the first part. So we need to escape that quote. There it is. Looks good. Let me run it again here. There it is. Looks good. Ordered list, these list items. And we copied it from the web page, so we probably got it right. Now what we want to do is make this string random. Let's make that string random. Now the thing here is it'll look something like this. we've got hexadecimal digits. It's a 0 through 9 and A through F. So we have to pick randomly between a set of those characters. How do we do that? Well, that's one part of the problem, how to select a random hexadecimal digit. The other part of the problem is how to get 6 of them. Huh? Yeah, you need a loop, right, to get 6 of them. That's right. So let's do the loop part first. You want to do the loop part first or the random digit part first?
Random digit's harder. Do the loop first.
Do the loop first? All right. So the loop is going to run exactly 6 times. Now, I have a loop. I got to run it exactly 6 times. What should come to your mind immediately is for loop. The for loops are used to do something in a known number of times. So let's use for int I equals 0, I is less than 6, plus plus I, increment I.
Now, you reuse I because it only exists for as long as the for loop, right?
Oh, no, we can't reuse. We're already using I, aren't we? No, we can't use I. Let's use J. Thank you for noticing that. We cannot reuse I. Let's suppose that our random digit is generated, but I'm just going to put it in there as D for now, okay? But we'll figure out how to get it to be random later on. Well, let's suppose it always comes up D all the time. When we have a digit, what do? We have to append it to the string. You know, I'm going to call it a hex digit. I want my code to be expressive. I want it to be readable. When the reader reads the name of a variable, I want the name to express its function and purpose in the program. That makes it easier to work with the code. So we have a color string, and this operation here is appending. So we append another string onto this existing string. So color string starts as an empty string. It's a string with no characters in it. And then this loop runs 6 times. And for each iteration of the loop, we append this hex digit onto the color string. It's just D right now, but we'll make it random in a moment. There it is. We're getting there. All right, let's create a random hex digit. There are 16 hex digits. Let me call it N, because I already used the word hex digit. Yeah, N equals rand, just rand, right? But then I want to, rand returns a value from 0 to some large number. But we don't want that. We want 0 through 15. 0 through 15, how many different numbers are there in 0 through 15? 16, because we're starting counting at 0. So let's divide by 16. Do we divide by 15 or divide by 16? Divide by 16, because a remainder could be 15. But if we divide by 15, we'll never get 15 as a remainder. So if we divide by 15, we're going to generate digits from 0 to 14. Does that make sense? Okay. So we get the random N. And now here we have our hex digit. Let's do it like this. I'm going to just declare hex digit, not set it to anything. If n equals 0, then I want to append a 0. Actually, I don't even need this anymore. I'm going to do it like this. This is our hex digit. So now the hex digit is an integer. I think this might be easier to read. And then I do color string plus equals 0. I don't need this anymore. So now I change hex digit from a string to an int. And I test the value of hex digit. If it's a 0, I'll append a 0 onto the color string. Else, if hex digit is a 1, then do something similar. How you format the lines is very important, and there are other styles. I'm just showing you one possible style here. That's my preferred style. And I can go into that later. So if hex digit is a 0, then we'll append a 0. If hex digit is a 1, then we append a 1, like that. And we do that. Oh, wait a minute. Let's not do them all yet, right? We could do it with 13 more to do. No, 14 more to do. Sorry, I'm off by 1. That's called the off by 1 problem, by the way. You've always got to doubt yourself whenever you say something. You say, am I off by 1? And I was off by 1. Yeah, you can use, you don't need else if. It's just less efficient. It takes more, CPU resources. You have to execute more instructions. You can just use an if here. But it's less efficient. Because the else, if the first if is true, and we do it, then we don't have to test the second if. Now, if the first if is true, if this condition is true and we execute that if, well, now we have to test the second one. We already know in advance it's going to be false. But now we're making the computer test it anyway. So that's inefficient. That's why we use else if here, because we know that if the first one is satisfied, there's no reason to do any more testing. We're done. Now, rather than doing the 14 additional lines, I'm going to test now. Make sure I got it right. Uh-oh. Line 26, there's a problem. Do you see that right there? Line 26. And we're going to have to finish up in a second here. Let me go to line 26. And look, see, hex digit is an integer. And I'm comparing it to a string. I need to compare it to an integer. There it is. It didn't repeat 6 times, though. What's going on?
Because it randomized a bunch of digits that weren't zeros and ones.
What's that?
Because there weren't a bunch of digits, it randomized a bunch of digits that weren't.
Oh, because we're dividing by 16. Oh, to test this, we'll have to divide by 2. There we go. Because we want either a 0 or a 1. We can't. If we get any other digits, then our else if structure doesn't get triggered, right? It doesn't add another digit. I mean, it's basically how you do the problem. Because we're running out of time, Let me do a few more here. I'll do them all. This is 16, and let's copy this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No, I totally screwed it up there, didn't I? I'm not going to have time to finish it. But basically, I'll do one more. Let me do one more. If the hex digit turns out to be 2, replace with a 2. And then here I'm using mod 3. And there's another error. But I think people are getting ready to go. So maybe we'll stop there. But this is how you do the problem. And next time, we'll continue and look at Lab 5.